Translating English to algebra. There will be many instances when we have to translate phrases from an English sentence into a mathematical expression or a mathematical equation. So this skill takes some practice to understand the English words and then to translate them into the math symbols. So it says it is important in exercise 1 to be able to recognize addition and subtraction in phrases, so the words. First, let's begin with some numerical work and then transition to expressions that contain variables, so meaning that algebra portion of it. So if I start out and I take a look at A, it says write a calculation and a result that represents a number that is 5 greater than 3. Okay? 5 greater than 3, well, that number is 8. Write a calculation and a result that represents a number that is 2 less than 9. So you could just think about what that number is in your head. So what's going on mathematically? It's 9 minus 2, which is 7. The key with that less than that we're going to have to remember later on is notice how it's written in English. 2 less than 9, but when we translate that into our math expression, the 9 comes before. Okay? Common error. Letter C says write a calculation and a result that represents the sum of negative 3 and 8. So sum negative 3 and 8, so that means plus, so my result is going to be 5. Write a calculation and a result that represents the difference of 20 and 12. So when it says difference, we know it's subtraction, and it converts right into the math expression in the same order. So 20 minus 12, so that result is 8. You guys are going to do E and F. Let's jump down to G. If Y represents a number, so now we're throwing in some variables into here, write an expression that represents the sum of Y, and so this is where we're going to start talking about the second number, a number 1 greater than Y. A number 1 greater than Y. So we're going to sum, Y is my first number, and then a number 1 greater than Y. So that's going to be Y plus 1. And you could even indicate that in parentheses as your second number. And then if we simplify this, that's going to be 2y plus 1. H says, if n represents a number, write an expression that represents the difference between a number, let's be careful how I read that and where I pause. It says, a number 1 larger than n, and, okay, so this is going to indicate that we're going to start to talk about the second number. 1 number smaller than n. So we know we're going to add a number 1 larger than n. So that's going to be n. 1 larger than that is plus 1. And then 1 number 1 smaller than n. So that's going to be n minus 1 is going to be my second. Okay. Oh, difference. Oops. I lied. Let's back it up. Difference means to subtract. Sorry about that, and I'll even change colors. Make sure you catch that. That's a minus sign. Okay? Let's hop down to, you guys are going to do 2A and B. Let's do C. It says translate each verbal statement into an expression and evaluate the expression if it is numerical. Okay? So write an expression for the quotient or ratio. So those are one and the same of 12 and 3. Well, quotient means to divide. Ratio is just division or fraction. So I tend to write my ratios or my quotients as fractions, and it says to find that value, which is 4. If x represents a number, write an expression for the ratio of x to 5. So x to 5. I guess you probably could even write it as the 2 colons ratio, but like I said, I tend to prefer the division to indicate that ratio or my quotient. So let's hop over to the next page. And we're going to get into some more complex things. So I'm going to leave A for you to do in 3. And then in B, it says, if n represents a number, then write an expression for 2 less than 1/4 of n. So let's be real careful there. Okay, there's that phrase that we have to change the order of our math expression. So 1/4 of n and 2 less than that. You're going to do C. Let's hop down to D. If x represents a number, then write an expression for 3 times the sum of x and 10. So the sum of x and 10, and 3 times that sum, we have to have our grouping symbols to indicate we're multiplying that whole sum by 3. You're going to do E. F, if x represents a number, then write an expression for the ratio, okay, so that's going to indicate our division of 3 less than, all right, I'm going to highlight that phrase there again to make sure that we indicate, we change our order, of 3 less than x to 2 more than x. So the 2 is going to indicate where the division is going to occur. So my numerator is 3 less than x, 2 more than x. You could write 2 plus x. I tend to write x plus 2. That's our standard form to put that variable first. You're going to do G, H, I, and J. And now let's go down to exercise 4. It says, I love this exercise. It's so cool. So it says, neat patterns can occur repeatedly when you play around with numbers. A fairly easy one occurs when, here's the pattern, when you add a number to 1 less and 1 more than the number. Do this for a few numbers of x and record the result. So first we're just going to play around in this calculation box here with numbers, and then we'll deal with pulling in the letters when it says, then prove a general pattern by writing an expression for the sum of a number with a number 1 less than and a number 1 more than. So right there that looks like a lot, but watch what we're going to do. So I'm going to pick one of my favorite numbers, super easy to work with. We're going to start with 1. So it says, when you add a number to 1 less and 1 more than the number. So what's one number 1 less than 1? It's 0. And what's a number 1 more than 1? It's 2. So if we add those together, you know that that's 3. All right, well, what if I start with 4? And I add 1 less than 4 to it, and I add 1 more than 4 to it, it's 5. And when I add that all up, I end up with 12. Okay, so I don't know, let's try 6. So add 1 less to it, that's 5, and 1 more than 6 is 7, and I add those up and I get 18. All right, what about if I go to 9? Whoops, I lied. The number I want to pick 8. 8. 1 more than that is 9. 1 less. Yep, let's go with this. So 15 and 9 gives me 24. All right, well, I always like to throw in maybe a negative. So -1, if I want to start with that. So what's 1 less than -1? Okay, that's -2. And what's 1 more than -1? And that's 0. And if I add those up, I get -3. So let's go over here and let's fill in this little chart. So what you're going to be focusing in on is the number we started with and its sum. And we're going to look for a pattern. What type of pattern are you seeing with the number we start with to its sum? The number we start with to its sum, hopefully. So we started with 1 and our sum was 3. We started with 4 and our sum was 12. We started with 6 and our sum was 18. We started with 8 and our sum was 24. Okay, we started with, we could add that one in, -1, and our sum was -3. Hopefully you're starting to see some kind of pattern between the number and its sum. So hopefully you're saying they're all multiplied by 3. Multiply by 3. 4 times 3. 4 times 3. 4 times 3. 6 times 3. 8 times 3. Negative 1 times 3. So our algebraic expression would look something like this. If we start with some number x and we add 1 more than x. So 1 more than x is x plus 1. And we add 1 less than x, which is x minus 1. If I combine like terms here, because this is just a big addition problem, I get 1x plus 1x plus 1x is 3x, and negative 1 plus a positive 1 is just 0. There's my pattern. It's always going to be 3 times the number. So just some cool patterns in numbers. Make sure that you finish up the questions that we didn't do, and we will see you in class.